All right, in this video, we're going to do a second day of solving trig equations. So before we get into the trig part, let's review some algebra concepts that we'll be utilizing in this video. So in this first equation, we have x plus 2 times 2x minus 1 equals 0. Right, so how would we solve that? Well, it's already factored for us, so we can use the zero product property, which means anything times 0 is 0. So if we could find a number that makes x plus 2 0, all right, that's going to be a solution. And if we could find a number that makes 2x minus 1 equal to 0, right, that's also a solution. So if x is negative 2 or if x is 1/2, that will satisfy this equation right here. All right, and that's the beauty of factoring. Anything times 0 is 0. So if you find out what makes any factor 0, it's going to be a solution. So if we plug in a negative 2 here, we get 0 times like negative 5, which is 0. So that checks out, that works. And if we plug in 1/2 into here, we would get 2.5, 1/2 plus 2 times 0 equals 0. All right. Now, for one like b, it's not factored, but we could just factor it and then do the same process. So both of these, it is a quadratic, it's not a trinomial, but both of these terms does have a factor of x. So we could pull out a 6, and we're left with 6x minus 11. And then now you could set each factor equal to 0 and solve, and we get our two solutions. X is equal to 0 and x is equal to 11 over 6. So the same properties apply even if it's a trig equation, all right? We're still going to treat the cosine of theta like x and solve it that way. Hold on, I have a chat here. Sorry, it's a lot of pop-ups on my screen. All right, so now for number 1, we need to solve this. So it's already factored for us, so that's great. So we're going to set each factor equal to 0. So I'm going to take 2 cosine of theta plus root 3. And if that equals 0, all right, if that's equal to 0, it doesn't matter what this is going to be. It's going to equal 0 because 0 times anything is 0. All right, now if we go to solve that, we get the cosine of theta is equal to negative root 3 over 2. All right, so now we got to find the solutions to this. Well, we got to find all values of theta between 0 and 2 pi that satisfy the cosine of theta equals negative root 3 over 2. All right, well, we need to find angles in quadrants 2 and 3 because that's where cosine is negative. All right, so these angles have to be in quadrants 2 and 3. And the reference angle has to be 30 degrees because if you have that chart memorized from the beginning of the year, all right, I know that the cosine of 30 is equal to root 3 over 2. So if I have a 30-degree angle or an angle with a 30-degree reference angle in quadrant 2 or in quadrant 3, that's going to satisfy this equation right here. So one of my answers is going to be 150, and the other answer is going to be 210. All right, 180 minus 30, 180 plus 30. Then we could just convert those two to radians. So 150 in radians is going to be 5 pi over 6. All right, and you could get that by multiplying by pi over 180. And then the other answer, 210 in radians, is going to be 7 pi over 6. All right, the reason why I answered in radians is because this was given in radians. So if it says find an angle between 0 and 2 pi, all right, that means you're going to answer in radians. If it said between 0 and 360, you would answer in degrees. All right, so right here are two of our solutions, 5 pi over 6 and 7 pi over 6. But we do have two more because there's another factor. There's this one right here, 2 cosine theta plus 1. All right, if that's equal to 0, right, if that's equal to 0, then it doesn't matter what this is equal to. 0 times anything is equal to 0. So we're going to solve that. Subtract 1, divide by 2. So I get the cosine of theta is equal to negative 1/2. All right, now I got to, again, find angles in quadrants 2 and 3 because that's where cosine is negative. And my reference angle now is going to be 60 degrees because I know from those values I memorized back from the beginning of the year, all right, that the cosine of 60 is equal to 1/2. So the cosine of any angle that has a reference angle of 60 is going to equal 1/2 or negative 1/2. So our other two solutions is going to be 120 or 240. All right, and then if we convert those to degrees, those are in degrees. If we convert that to radians, all right, 240 times pi over 180 would be 4 pi over 3. And 120 times pi over 180 would be 2 pi over 3. All right, so those are our other two solutions. So that's 4 total. And you should expect 2 solutions from each linear equation. And since this got factored into 2 linear factors, we had 2 from here and 2 from here, and that's why we had 4 solutions total. All right, 5 pi over 6, 7 pi over 6, 2 pi over 3, 4 pi over 3. All right, if you have a question, let me know. If not, let's try number 2, which is just like number 1, where it's already factored for us. But now we have sine. All right. So first thing we're going to do is set each factor equal to 0, because the hard part, the factoring part, was already done for us. So we're going to set the sine of x minus 1 equal to 0, and also 2 times the sine of x minus 1 equal to 0. And so this time I'll do them both together at the same time. All right, so we're going to solve for the sine of x. We get the sine of x is equal to 1. Or over here, if we add 1 divided by 2, we get the sine of x is equal to 1/2. All right, now both of these factors coincidentally equal positive ratios, which means if we're doing this for sine, all right, we're looking at angles in quadrants 1 and 2, because that's where sine is positive. All right, and we're only looking for angles between 0 and 360, so we don't have to worry about coterminal angles. All right, so now for this one, I'll color coordinate it. The sine of x is equal to 1. All right, you just need to know that the sine inverse of 1 is equal to 90 degrees. All right, so you can know that just by your table or by your unit circle. All right, but the sine of 90 is equal to 1. So my first answer is going to be 90 degrees, or in radians would be pi over 2. All right. Now, when you have these quadrantal angles, that's when you're going to get just one answer instead of 2, like in the next one. All right, because there's only one angle that has a 90-degree reference angle where sine is positive, like in quadrants 1 and 2. Whereas for the next one, there's 2 angles that satisfy the sine of x equals 1/2, because I know that the sine of 30 degrees is equal to 1/2. So any angle with a 30-degree reference angle would also satisfy that equation right there. All right, but you also have one in quadrant 2, because that's another quadrant where sine is positive. So that angle is going to be 150 degrees. So we get our 2 answers: 30 degrees, which is pi over 6, or 150, which is 5 pi over 6. And now we got our 3 solutions: pi over 2, pi over 6, and 5 pi over 6. All right, now in number 3, it's not factored for us, so we have to factor it. So this would be something like, let me zoom up, let me scroll up a little bit. So this would be if we had something like x minus 2y times x equals 0. Right? The only difference is instead of x, I have cosine of x, and instead of y, I have the sine of x. So if I was solving this, I could just factor out both these terms have a common factor of x. I could factor out an x. And then I could then set each factor equal to 0. Same thing here. Both of these terms have a cosine of x factor. So I can pull out the cosine of x. And then I'm left with 1 minus 2 times the sine of x. Now we're just in the same kind of part of the problem where we were in questions 1 and 2, where we can now just set each factor equal to 0 and then solve. So we could take the cosine of x, set equal to 0 and solve, and take 1 minus 2 times the sine of x, and set it equal to 0 and solve. So if we subtract 1 and divide by 2, we get the sine of x is equal to 1/2. All right, now we got to find all the values of x. All right, this should say x, not theta. That's a typo there. That satisfy both of these. So for this one, we have the cosine of x is equal to 0. Well, 0 isn't positive or negative, so it doesn't matter what quadrant we're in. But I know that the cosine of 90 degrees is equal to 0, which means any angle with the reference angle of 90, the cosine of that angle would also equal 0. So 270 would also work. The cosine of 90, the cosine of 270. All right, both of those work. So in radians, that would be pi over 2 and 3 pi over 2. And again, the way I'm getting these answers is I'm just doing the cosine inverse of 0, which you could do on a calculator. All right, but if it's ever the sine or cosine inverse of 0, 1/2, root 2 over 2, root 3 over 2, or 1, all right, or negative any of those numbers, you should know that without a calculator because those are the values that you have memorized from your table or from your unit circle. All right, same thing with tangent. If it's the tangent of an angle equals 0, root 3 over 3, 1, root 3, or undefined, all right, same process. Okay, so we have two of our answers so far, right here and here, pi over 2 and 3 pi over 2. Then we're going to do the same thing here with the sine of x equals 1/2. But 1/2 does have a sign. All right, 1/2 is positive. And sine is positive in quadrants 1 and 2. And I know that the sine of 30 degrees is equal to 1/2. So I know 30 degrees is an answer, or an angle with a 30-degree reference angle in quadrant 2 would also work. So 30 degrees in radians would be pi over 6. So that's another answer. And 150 degrees, that's an angle with a 30-degree reference angle in quadrant 2, all right, would be 5 pi over 6 in radians. All right, so that's our other answer. So there we go. Those are our 4 solutions to number 3. All right, so if it's not already factored for you, like in 1 and 2, then just try to factor it. And anytime you try to factor something, always look for the GCF first. All right, pull that out, and then it just set each factor equal to 0, and then it becomes just like the previous lesson where we're solving these linear trigonometric equations, and we either do sine inverse, cosine inverse on our calculator, or use our memorized values to find out our answers. Okay, number 4, again, not factored, so let's go ahead and factor it. All right, both of these terms here have a common factor of the tangent of theta. So we could pull out tan of theta. And we're left with, we factor that out, root 3 minus 2 times the sine of theta equals 0. Okay, now that it's factored, we could just set each factor equal to 0 and then solve for tan of theta and sine of theta. All right, so tan of theta is already solved for here. If we subtract root 3 on both sides and then divide by -2, we get that the sine of theta is equal to positive root 3 over 2. Now we got to find out which angles satisfy these two equations here. The tan of theta equals 0 and the sine of theta equals root 3 over 2. And as long as they lie in that range, then we know that they work. And so this is nothing new. We're just putting a bunch of things that we learned already together. How to solve like a quadratic equation in algebra. And how to do inverse trig, which is what we did a couple of sections ago. All right, so now we got to do the tan inverse of 0. So if you did this on the calculator, it's only going to give you angles between 90 and -90. And we know that the tangent of 0 is 0. So a 0-degree angle would work. All right, but any angle with a reference angle of 0 would work. So like also 180 degrees would work because that also has a reference angle of 0, and it lies in this range between 0 and 2 pi. So we get two of our solutions, 0 and 180, which in radians would be pi. All right, now we got to find the other two solutions by solving this equation here. All right, so I know that the sine of 60 is equal to root 3 over 2. So we got to find angles with 60-degree reference angles that satisfy this equation here that I underlined in purple. So it would be 60 degrees because it's positive root 3 over 2. So it's got to be in a positive sine quadrant. All right, and it could also be a 60-degree angle in quadrant 2, which would be 120 degrees. Convert these to radians, and you get pi over 3, that's 60 degrees in radians, and 2 pi over 3, that's 120 degrees in radians. And those are our four answers. All right, so again, just like 1 and 2, but like 3, we have to factor it first, and then set each factor equal to 0, and it ends up being just like the previous lesson that we did, just using sine, tangent, inverse. All right, now for number 5. And you know what? I should show you how to. I'll show you how to check your answers after this too. I should be doing this, by the way, but I forgot. I'll do it in the next two. All right, 2 times the sine of x minus the sine. Sorry, 2 times the sine of x squared minus the sine of x minus 1 equals 0. So remember that the sine squared of x, when it's written like that, is the same thing as like the sine of x and then squared, and then minus the sine of x and then minus 1 equals 0. So we could treat this just like it's 2 times x squared minus x minus 1. All right, so that's a quadratic. So we would try to factor it first. So look for two numbers that multiply to -2 and add to -1. So that would be -2 and +1, which means we could break up this middle term as -2x plus x minus 1. All right, then we could factor by grouping and pull out a 2x. And then here, there's no common factor, so there's nothing to pull out other than a 1. And then we could pull out x minus 1, and we just factor that. All right. Now, that wasn't the equation. What I did was I replaced x with the sine of x. So I'm just going to put the sine of x back. Put it right back where I found it, in for x. Now I have the sine of x minus 1 times 2 times sine of x plus 1, all right, equals 0. Okay, now I could set each factor equal to 0. So the sine of x minus 1 equals 0. And that gives us the sine of x equals 1. All right, and then if I set the other factor equal to 0, subtract 1, and then divide by 2, I get the sine of x equals -1/2. Now I have to find the angles between 0 and 2 pi that satisfy these two equations. So the first one is just going to be 90 degrees, or pi over 2, because I know that the sine of 90 is equal to 1. And the only other angle between 0 and 2 pi that has a reference angle of 90 would be 270. But 270 is in between quadrants 2 and 3, where sine is negative. So because it's +1, I'm only looking for angles in between quadrants 1 and 2. All right, so that's one of my answers right there. All right, the other one has to have a 30-degree reference angle because the sine of the angle is equal to -1/2, and I know the sine of 30 is equal to 1/2. All right, so A, S, T, C. All right, but they have to be negative in negative sign quadrants. So it has to be in quadrants 3 and 4. So the other angle would be 210, which is 7 pi over 6. All right, and then this other angle would be 330, which is 11 pi over 6. All right, so I know that kind of looks kind of weird, but or it's kind of crammed in there, not really weird, but those would be our three solutions. All right, now remember, let's check our answer with the calculator. All right, remember what these were: 90 degrees, all right, 210 degrees, and 11 pi over 6 was 330. All right, what I'm going to do now is check our solution with the graphing calculator. And it doesn't have to be a special graphing calculator. It could be any graphing calculator. It doesn't have to be a CAST. It could be any graphing calculator. What I'm going to do is I'm going to graph the left side, like y equals that. And I'm going to graph the right side, y equals that. So anytime you want to check an equation on a calculator, simply graph both sides and see where they intersect. And since I'm only looking for angles between 0 and 2 pi, which in radians would be between 0 and 360, I'm only going to look at the graph between 0 and 360. Okay, so this is how you check your work when you're doing an equation. You can do any equation like this. Well, I will ask you to show your work, so don't rely on this, but it's a good way to check your work. All right, so 2 times the sine of x. Now, how do you write that squared? I don't know if it's going to work if you put the squared there, so I would just square the whole thing, because that's what the sine squared of x means. It just means you square the sine of x. All right, minus the sine of x minus 1 equals 0. All right, so we graph it, and let's see. It looks like I typed it in right. If I didn't, we'll find out later. All right, now I want to see what if I go to menu settings, I can see that my graphing angle is in radians. So I might want to change that to degrees. I don't know if this worked. Yeah, let's graph, zoom, fit. All right, I typed something in wrong. Let me try that again. Zoom standard. So is it 2 times the sine of x squared minus the sine of x minus 1? Oh, I put equals 0. I'm silly. I'm sorry. I should have just graphed the left side. And then also graph the right side. 0. Now I want to see where these intersect. Now the reason why the graph looks weird like this is because my graphing angle is in radians. There's in degrees. If I put it back into radians, all right, we can see, they have, a bunch of intersections here. Okay. Now I could figure out what my answer is in radians, which would be pi over 2, 7 pi over 6, and 11 pi over 6 by finding where these intersect. Now the first intersection is at 1.57, which is equal to pi over 2. All right. The other intersection would be at 3.76, which in radians, which in degrees is 210, or in radians in terms of pi would be 7 pi over 6. All right. The reason why I like to do this in degrees is because I'm more used to angles in degrees. So you can do it any way you prefer. But if we're looking for solutions between 0 and 2 pi in radians, that's between 0 and 360 in degrees. So I have to change my window setting to be between 0 and 360. And then I see my three solutions there, there, and there. And those are going to be the same three that I got when I solved it by hand. 90 degrees, 210, and then 330. All right, so you could check any of these with the calculator by graphing both sides and seeing where they intersect, either in radians or degrees. And then remember, you could change your graphing angle from radians to degrees by hitting menu, settings, and then doing it that way. If you do it up here, it's not going to change your graphing angle. That's for your calculator angle. All right, so if you want to graph we usually graph in radians, which is why we never really talk about this. But if you want to graph in degrees, all right, menu settings, graphing angle. And if you have a different type of calculator, let me know and I can show you how to do it on your calculator. All right, last one, number 6, looks like one that we should try to factor because it's a quadratic. We're going to treat this like a quadratic because we got cosine squared and cosine. All right, now with quadratics, we solve them by factoring, or if that doesn't work, do the quadratic formula or complete the square. So let's try to factor it first. Now, anytime you solve a quadratic, you want to get 0 on one side. Okay? Um, Now, does this factor? Well, we got to find two numbers that multiply to 10 and add to 11. And I think that would just be 10 and 1. So this can be factored. All right? So now I'm going to, if it didn't factor, we'd have to do the quadratic formula and all the other steps would be the same. So I'm going to break this up as 10 cosine of theta plus 1 cosine plus 5 equals 0. Then I could factor out 2 cosine here. And if that confuses you with like the cosine, just temporarily like substitute x in for cosine. And then it becomes just an algebra problem. All right, so then we could factor out a 2x. And then in the last two terms, we could factor out a 1. Okay, then here we could factor out the x plus 5. And we're left with x plus 5 times 2x plus 1 equals 0, which is the same thing as the cosine of theta plus 5 times 2 times the cosine of theta plus 1 equals 0. Okay, so then we set each factor equal to 0 and solve. And we get the cosine of theta is equal to negative 5, and the cosine of theta is equal to negative 1/2. All right. So now we got to solve that. So if we do cosine of theta is equal to negative 5, and the cosine of theta is equal to negative 1/2. All right, remember that sine and cosine have ranges between 1 and negative 1. All right, the sine of an angle and the cosine of an angle can't equal anything bigger than 1 or less than negative 1. All right, think about it. If you think of the graph of sine or cosine, they both, oops, I wrote sine twice. They both go in between 1 and negative 1. Like sine, the range goes between 1 and negative 1. Cosine, the range goes between 1 and negative 1. All right, they never go outside of that range. All right, also because the sine of theta is equal to the opposite leg divided by the hypotenuse. The hypotenuse can never be smaller than the opposite leg. So opposite over hypotenuse can never be bigger than 1. Same thing with cosine. The reason why I say that is this right here would have no solution. So if you ever have the sine or cosine of an angle, not tangent, tangent's different, but the sine or cosine of an angle equals something greater than 1 or less than negative 1, like in this case, negative 5, there's no solution to that. Okay? Then the other one is just like the other problems that we did. So cosine theta equals negative 1/2. All right, so I know that the cosine of 60 degrees is equal to 1/2. All right, you should have that memorized. If you need help memorizing it, let me know. I'll be happy to go over it and show you different ways to memorize it. Okay, but it has to be, since it's negative, in quadrants 2 and 3. All right, so 60 degrees, 60 degrees. All right, so quadrant 2, that would be 120. And quadrant 3 would be 240. So 120 degrees in radians would be 2 pi over 3. And then 240 would be 4 pi over 3. All right, and then those are two solutions. And that's it. It only has two solutions. If you want to graph this to check your answers, all right, we already have it open, so we might as well just use the same window. So that's the beauty of doing a bunch of these. Once you do one, then you could just, edit it without having to retype everything. So you plus 5. All right, and then we get our two solutions, 60, and then the other one, I don't know why we got 60 though. We got -1/2 and I did this. Did I mess up somewhere? Yeah, whatever. I might have made a mistake somewhere, but hopefully you get the point. All right.